But 3 days and 200,000 miles into the flight, Mission Control did miss the significance of a cryptic message from the astronauts.
Any idea where the N4B is with respect to us?
In my early years, I came to believe very strongly that there must be other civilizations out there and that the galaxy was teeming with life. And so I was a strong supporter of the search for extraterrestrial intelligence. My belief wasn't based on any real hardcore scientific arguments. It was just the impression that I had that the galaxy was such a big place. And I didn't give the other side of the equation much thought. In other words, there's two sides of the equation. There's the number of stars, the number of trials, if you will. But the other side is the factors. It takes a lot of factors to have a habitable planet and a planetary system.
For Gonzalez and other astrobiologists, these factors, required for the Earth's habitability, became the focus of extensive research.
We've demonstrated in dozens of different ways the laws of physics and chemistry that pertain in the laboratory anywhere on Earth apply anywhere in the solar system, apply anywhere in the galaxy, and in many cases...
Remember what this guy said, the laws apply everywhere.
Yep.
Because they're going to say otherwise very shortly, I'm sure.
And
they're going to
just going to nip it in.
They're confirming.
I'm just going to nip it in the bud.
All right.
I just also want to nip this in the bud that just before they actually do sort of claim otherwise, is that these factors are probably going to... I haven't seen the films, so I can't really say where it's with absolute certainty they're going to say this. But yeah, all the factors that they're going to mention assumes that life is only possible the way we know it here on Earth. There can be absolutely no other forms of life. That has to be carbon-based, that has to have DNA, which in itself limits the temperature, it limits certain limits on the conditions you can have. Even though the conditions on Earth even though life as we know it can actually thrive in a wide variety of conditions. Just look at Yellowstone Park. We have bacteria that can survive in 100 degrees plus water. And hydrogen sulfide and all these other noxious chemicals. So I'm just not too comfortable with the way they're saying that life cannot be, that there's several factors needed for life, when they should really say there's several factors needed for life that we know life
as we know
that we know how life is, life as we know it on this planet.
Yeah.
Right, they're kind of limiting themselves on the amounts of other different ways that life could exist. Now I mean to really emphasize that could exist.
Yeah.
Their starting position is a terrestrial class planet with water.
It is now widely recognized that the chemical properties of water are exquisitely suited for carbon-based life. These properties include water's ability to dissolve and transport the chemical nutrients vital to all living organisms, and its unmatched capacity to absorb heat from the sun, a process critical for regulating the Earth's surface temperature. In liquid form, water is an extraordinary substance, and its existence hinges upon another factor essential to complex life: a planet's distance from its home star.
It's like what they say in real estate: location, location, location. A habitable planet lives in what we call the Goldilocks zone. It's not too hot, it's not too cold, it's just right. And when I say just right, I mean just right for water.
Liquid water really helps define the habitable zone. If it's too hot, again, they'll...
It's actually not just a question of the distance. For example, you can have geothermal heat. If you look at some of the moons of Jupiter that are way outside the Goldilocks zone of our sun, they are heated by tidal forces that mess with the surface, mess with the internal structure, and it's perfectly possible for the heat generated by that to melt water and keep it in a liquid form. I don't know if that's the case. There's one moon, I can never remember which one, if it's Europa, I think, that has
Is
liquid
that-
water underneath
Is that
ice.
Titan?
Europa.
No,
Also,
Okay.
aren't there places?
I think it's Europa.
Correct me if I'm wrong, but
Okay,
if you
yeah,
go
okay. I always
to,
get the two mixed up.
sorry, correct me if I'm wrong, but if you go up towards Antarctica or places around Alaska, you can jump into the ocean. It will be minus 10 to minus 15, but it will still be liquid because the water is continuously moving. It doesn't have time to stay put and solidify into ice.
Just
And
because
just on the whole thing on the Goldilocks zone, it's actually not so what's the phrase? Sorry, it's not actually so specific or so narrow that if the Earth was maybe 5 meters one way or 5 meters the other way or miles or whatever, that's it. That everything's fucked. There's actually a
No.
good bit of leeway with it.
Yeah.
Yes.
Mars is actually in the Goldilocks zone as well.
Yes.
Water just boils away. You just can't get condensed water. It's too cold, as in Mars today. It freezes out.
Stop.
When was this made, by the way?
Mars is not necessarily too cold for liquid water. The problem is that Mars is very small. It doesn't have a lot of gravity. That means it doesn't have a very thick atmosphere, so that means lower pressure, and that affects the boiling point of water. If you take ice to Mars and you put it somewhere where it's actually above freezing, as we think of it, 0 degrees Celsius,
Yep.
it will evaporate. Well, actually, forget the 0 degrees. By the way, I'm messing up. If you take it above the melting point at that pressure, it won't melt. It will vaporize. That's what I mean.
We need an oxygen atmosphere, and the oxygen,
Stop.
nitrogen.
yeah, I knew this would get you good.
No! We don't need oxygen. Well, the life as we know it doesn't even... Okay, we as mammals, animals, need oxygen, but bacteria don't, fungi don't,
Yeah.
some protozoa don't. These guys can just do fine without oxygen. In fact, the bacteria I'm studying, Shunella, actually can do well with using iron oxides, or iron, gold, silver, plutonium, uranium, DMSO, magnesium. Sorry, I can't remember all the electron.
So what you're saying is you're
acceptors.
studying.
Yeah, but they can use a lot of shit.
Yeah.
And weren't the first bacteria on Earth, didn't they breathe sulfur?
Yes,
I think
the
so.
fact-
It was. And,
Correct me if
yes,
I'm wrong on
sulfur.
this, but what I remember watching a documentary when I was a kid. This very well may have been refuted since then, but wasn't the fact that the early bacteria figuring out how to photosynthesize and create oxygen nearly killed all life on Earth because they couldn't process it?
Yeah.
Yeah.
That was some of the first adaptations that life had to do, wasn't it?
Yeah. Oh yes, but once that kicked in, it was a great advantage, no doubt. I'm not saying that oxygen isn't fantastic. You know, nobody loves oxygen more than I do.
Yeah.
But it's not absolutely essential for life.
Yeah.
As just life, not life as we know it, but I mean just talking about life in general. It's not absolutely essential. There are other terminal electron acceptors that life can use. And this is also assuming about nitrogen. This is also assuming that that life has to exist as we know it. Life has to use carbon as its backbone. Life has to use oxygen as its. It's just, life can't exist in any other form, in any other way. This is the way life has to exist. And there's no other possibly better, maybe life out there that possibly might be out there using a different system. It may be better, it may be worse. I think actually even using the terms better or worse is a little bit ridiculous because, it's
Life
evolved
is
to
life.
adapt in that system because we wouldn't live in that system. But sorry, I'm just The stupid.
Oh, and I've just noted we've had 150 viewers, so thanks everyone for watching and tuning in. Hope you're enjoying it.
Thank you for not having anything better to do.
We appreciate
also,
that.
Marty, I would just like to point out that I'm having someone screaming in my ear that they want to rip into you because surely a gas giant close to its parent star would have its atmosphere blown away. Eventually, what they're saying.
Well,
Bear in mind, I'm
depends
having
on
to
how
paraphrase.
close. If it's very close, then yeah, probably.
Tree is broken out already.
While one side of the Earth continually faced the sun and increased radiation from solar flares, the dark side of the planet would lay shrouded in perpetual cold and ice. It is unlikely complex life could tolerate these drastic extremes in temperature.
A lot
And from
of
the dark side of the Earth,
to
the
have
Sith shall rise.
yielded complex life, absolutely.
The number of factors that have been postulated has grown. Currently, the typical number you would see is, in a typical list, would have something like 20.
We find that we need to be at the right location in the galaxy, that we're inside the circumstellar habitable zone of the star, that we're in a planetary system with giant planets that can shield the inner planets from too many comet impacts, that we're orbiting the right kind of star that's not too cool or not too hot, that we're on a planet that has a moon that can stabilize the tilt of its axis, that we're on a planet that's a terrestrial planet, a planet that has a crust that's just thick enough that it can maintain plate tectonic activity, but it has enough heat in its interior that it's still circulating its...
He did say that we're surrounded by bigger planets that shield us from comets and meteors. I'm trying to remember, wasn't there this big group of life millions of years ago? I'm trying to remember what happened to them. Oh yeah, a big fucking meteor smacked into the side of the Earth and killed them all.
Yeah, and we are getting...
Well, it would happen a lot more often if it weren't for the gas giants.
And for the moon. Isn't the other side of the moon basically one giant fucking crater?
But again, the problem with what they're saying is they're using a sample set of one for this.
Yeah.
Life could arise under different circumstances. We just don't
And those big-ass planets, if you look at any solar system we've discovered, have we found one that consists of nothing but small planets? No. It seems like it's pretty common to have big planets in a solar system.
All right. Carry on.
Yep.
Liquid iron cores that can generate a magnetic field, that has an atmosphere that has enough oxygen to allow for complex organisms to survive, that has enough water and enough continents to allow for the diversity of life for an active biosphere.
Wait a second. Enough continents.
Why would that be necessary?
Because there was at one point we only had one continent.
Yeah.
And the amount of continents, because of tectonics, changes all the time. I've never heard of that being a requisite for life. I think you need... You don't even need a continent. You could have marine life quite happily going along their business, couldn't you?
Have you not seen Waterworld?
Yeah. I don't want to remember that. It's not that bad, but again...
I think their problem was they had too much stuff.
Yeah.
Let's not review a movie here.
Yes.
We're already ripping one apart.
Yep. Let's carry on.
Atmosphere that you need to support complex creatures such as ourselves. All these factors have to be met at one place and time in the galaxy if you're going to have a planet as habitable as the Earth.
How do you know?
Which you need for complex and even technological life.
As we know it.
In an attempt to
here we go,
estimate the
Marty.
probability of attaining this...
Whoa. So now they're talking about not just complex life, but complex life with technology.
Mm-hmm. They kind of slipped that one in there at the end.
So there could be intelligent life elsewhere that doesn't have technology, so they don't count. What?
Yeah. And if you look at the screen, Marty, look what's coming up.
I saw it.
But this is going to be...
But the Drake equation has to do with civilizations that we can detect, not civilizations that exist.
Yep. Anyway, I think we've got like a big math rant coming from Marty in a second. So we're going to let this play.
this combination of factors simultaneously, some researchers have developed equations assigning a conservative 1 in 10 value to each factor deemed necessary for advanced life.
If every element has to be there at the same time, you have to multiply the probabilities. And that's what makes the probability at the end so small. You've got 10% of this and 10% of that, and these things rapidly multiply to exceedingly small numbers. The numbers on the order of 10 to minus 15, which is 1/1000th of 1 trillion. And it's a number like that that you have to compare to the 100 billion stars that are in the galaxy. 100 billion is a very large number.
Whoa. Why just our galaxy?
There's other galaxies.
Yeah.
Let's say there is
And
only
even,
one.
even if we were to grant that probability, you're dealing with an entire fucking universe.
And
Yeah,
also,
You're bound to at least find it at least once or twice.
improbable does not
Yeah.
equal impossible.
Exactly.
Also, can I just point out, if they're saying that, this is really improbable, we're here. So it's not that improbable.
Yeah.
And
Well,
if
it's certainly
we're...
not impossible.
Yeah.
It's not impossible if it's...
Like, even if that number's really big, it's happened at least once, so...
And
You know,
there's an
what's there?
awful lot of stars out there,
Yeah.
and an awful lot of planets out there, and an awful lot of galaxies out there. So it's probably happened a few times.
Yeah.
And where are they getting these probabilities from? That's what I want to know.
I
But,
think...
I think they're being pretty conservative. I'm not going to argue with it.
The Drake equation is a bit of...
relevant.
I think the Drake equation is a bit of guesstimation, isn't it?
Yeah.
There's
it is.
some guesses in there.
And
I think-
typically you end up with,
Yeah.
anywhere between 1 and 100 civilizations, depending on just how conservative you are.
Yeah.
I typically end up with around 10 in our galaxy, and that's perfectly consistent with the fact that we haven't found any yet.
Mhm.
Because if you
Isn't
take
there-
those 10 and look at how, assume a fairly even distribution, they're so far away that we're not going to find them.
Question, isn't the current estimate of how many planets are habitable for life somewhere around 60 billion? Something to that effect.
But again, it's
That
estimates.
they were... Sorry, this came from an article I read on BBC News, I think it
Okay.
was, where they were talking about how new Earth-like planets have been found, bringing the total number up to this
Yeah.
within this certain region. So the estimate is this for the bigger.
Yeah.
This is purely an estimate sort of thing.
Yeah, like someone in the IRC chat room is that moons, dwarf planets, and or even asteroids could sustain some kind of life.
Yeah,
It's all possible.
correct.
I mean, comets as well. It's not impossible. Would it be impossible for a comet to sustain life?
Well,
Bacteria could sort of theoretically.
yeah, I don't see how that could work because a comet has. I mean, if it's out there in the outer solar system, it's
Yeah.
going to be frozen, and when it moves inward, it's going to experience very extreme conditions.
Yeah.
So I don't see that happening, but yeah.
Number. But 1,000th of a trillionth is much, much smaller.
Okay.
On their face value, these probabilities are speaking. What they're telling us is this can't happen, or this
No.
is very
No.
unlikely to happen in the galaxy.
Said very
And
unlikely.
That's where the evidence is pushing us.
There are many probabilistic resources in the galaxy, but on the other side of the coin are all these factors that you need. You have to get just right in order to have just one habitable planet like the Earth. And that leads me to conclude that yes, we're rare in the galaxy.
We may be alone in the galaxy. That
While a
doesn't
growing body of
matter. Even if
scientific evidence-
even if there's one civilization per 1 million galaxies, that would still mean that in the universe that we can observe, there would be let's see, hundreds of thousands of civilizations anyway.
Yeah.
So shut up.
Also,
It's
isn't...
Carry
He
on.
keeps saying that everything has to be just like this, but we've been going through this saying, well, you could change that. That doesn't need to
Yeah.
happen. You don't need that. And also, couldn't you completely remove one of the... Fuck, I can never remember how this is phrased. You could completely remove one of the primary forces and still have the ability to make life, like they've run equations.
Yeah.
You
That's what I said.
probably you could remove the weak force, and it's possible you could even remove gravity.
But again, they're using life as we know it on this
Yeah.
planet.
And adding the requirement that it be detectable by us because they must have technology.
Yeah, that was
And that,
very.
sorry, you're changing the subject. Are we talking about life or life that we can communicate with? That's not the same thing.
Like that's a big shifting of the goalposts. They
Yeah.
did.
Especially since not only would they need to have a form of communication, it would have to be one very similar to our own, because
Right.
radio waves, whereas they could use something completely different.
Yeah,
They could communicate through infrared communication, for all I know.
right.
Carry on.
Like,
We support this hypothesis. Does the possibility that our planet is rare within the galaxy imply anything about its significance?
No.
Nope.
Recently, astronomer Donald Brownlee considered this question in the best-selling book Rare Earth: Why Complex Life is Uncommon in the Universe.
There's
Not
a general
period.
feeling that nature wants to make Earth-like planets, and that naturally that life will evolve on them and naturally evolve to something like us. And yet the conditions, the environmental conditions on the planet that would allow more complex creatures similar to people or plants and animals is very rare. And so we wrote the book Rare Earth to point out that the Earth is actually a rather special place.
Brownlee contends that while relatively simple microbial life may thrive on planets throughout the universe, planets capable of sustaining complex life are
It's
exceedingly
only complex life they're talking about.
Well, the entire universe is highly hostile to life. If you compare all the known places in the universe, none of them compare to Earth.
You compare all the known places in the universe to Earth. How's he done that?
Well, all
Magic.
the known places, sure. We don't know of any other place that there can be life, as we know it.
But even then, we still don't
But
know.
so what?
We don't know exactly if there's life on them or. But like I
Exa-
said,
exactly.
they keep changing between life to complex life to technological life when it suits them. And this.
If you take a look at the parts of the universe we know of, yes, there is no life, but there's so much we don't know. We don't know how many planets there are around, that star over there. There could be life on one of them. We don't know.
We live in a very special environment that provides what we need, provides air, provides food, stable conditions, so that the Earth is almost like a giant organism where its systems are interacting in a way that allows animals to survive. But the real question
Because
is,
they can adapt.
Why did this happen? Was it just a matter of luck?
that's evolution, and that's by Satan.
No,
If
it's
you
not
look at
luck, it's
thousands of
called
planets,
evolution.
Only a small fraction of them, very small fraction, will be truly Earth-like.
Oh,
And
that's
we've already
we are
established
very
that
rare.
they
We
don't
did win
have to
the
be.
cosmic lottery. So we're
Also,
lucky planet.
can I just
We're just
say
very
stop?
fortunate.
Because he's changed the goalpost yet again.
Yeah.
From not just technological life forms, but Earth-like. We're
Yeah.
products of our environment. They will be products of their environment. Where's the big
It's
problem for him?
he's taken he's taken this narrow-minded Hollywood view of extraterrestrial life, where they're just
Yeah,
grey, humanoid like men.
Yeah, they have to
They
look
could be
like
anything.
humans, possibly with something funny with their foreheads
Right, shall we carry on?
Vulcans.
or pointed ears.
Oh, because I think there's another bit of math coming in here, Marty.
Uh-oh.
Fortunate place.
Oh god, I seen a jackpot machine. This never ends well.
When you consider chance as an explanation for a planet like Earth, you
Who
have
ever
to
said
look at it
chance?
in the context of the universe as a whole. While the odds appear astonishingly small that you'd get all the right ingredients to support complex life at this one place in the galaxy, You have to keep in mind that our galaxy is just one of perhaps 100 billion galaxies in the observable universe. Still, logically, I think you have to ask yourself, what if this convergence of factors didn't come about as the result of simply a cosmic lottery or a mere fluke or luck?
Present a mechanism.
What if it's the result of some larger underlying purpose or design? And if the
Here
Earth
we
does
go.
exist
Present
for a
your
purpose,
evidence.
is there any way that we could tell?
No, I don't see how. But
On
Present it.
October the
Go ahead.
24th, 1995, a red
Life could have evolved to use gamma radiation or X-ray radiation or something like that. There's really just a narrow part of the spectrum that would be useful to life processes. Well, as it turns out, that's also the same narrow part of the spectrum.
Hold on. Did he just admit that life could possibly evolve to use gamma radiation and then just say, well, life can only use this certain part?
Yep, pretty much.
Okay, have you not noticed that the goalposts have been shifted so much
Oh, yeah.
that the chance of scoring a goal is fucking 0?
Yep.
Like, you have a sumo wrestler standing in front of a teacup.
Yep.
That's like a clear example. Oh, life can use it, but it's not. But it has to be at this. It has to be fixed.
Yeah.
Even though it's possible that life could use it if it was different.
And
But
you've
who
already...
cares about facts?
And
Oh,
you-
they just get in the way.
And Kitch, you did just give an example of a fungus that's already doing this.
Yeah.
The Chernobyl one.
That is the most informative about the various structures that we discover in the universe around us.
These specific frequencies that enable plants to manufacture food and astronomers to observe the cosmos represent less than 1/trillionth of a trillionth of the universe's range of natural electromagnetic emissions.
Your point.
Fortunately, it is the type of light our sun produces in abundance,
Yeah.
and that most easily
Because
penetrates the
we-
filtering
So
shield
we
of
have
our
evolved
atmosphere
to make
reach
use
the
of
surface
that.
of the Earth.
Also,
It's a remarkable
we use...
coincidence.
Natural selection, bitch.
Also, does he not realize he's saying that, oh, we use this tiny gap to view everything? We also created cameras that can view infrared light, which we have pointed outwards, and that's how we've discovered a lot of what we've discovered.
And
But
we have
no,
X-ray machines and things like that.
those don't exist because of science and reasons and magic, and because this sciencey person said so, apparently.
Okay. Carry on.
That the kind of atmosphere that's needed for complex life like ourselves does not preclude that life from observing the distant universe. It's a surprise. It's something that you wouldn't expect just chance to produce. Why would the universe be such that those places that are most habitable also offer the best opportunity for scientific discovery?
No, they don't.
We covered that one.
The best place for scientific discovery would also be in the most hazardous places, like, I don't know, outside the solar system
Or even
or the
in
galaxy.
or in the heart of a nuclear reactor. There'd be lots of science to discover in there, but we can't go there.
In
would be
1997,
awesome to
Guillermo
go inside a black
Gonzalez
hole.
began a study of the Earth's specific location within the Milky Way galaxy. It would eventually lead him to more evidence of a correlation between life and discovery.
Eh? How?
Just as our location in the solar system is optimized for habitability, so is our location in the galaxy.
How?
We inhabit a spiral galaxy, which means it's highly flattened, it has a spherical bulge in the center, and it has spiral arms. And we live about halfway between the center of the galaxy and the edge.
Working closely with astrobiologists Peter Ward and Donald Brownlee, Gonzalez compared our position in the Milky Way to other regions within an often hostile galaxy.
The galaxy has a lot of dangers, and perhaps the most dangerous place in the galaxy is the galactic center.
Well, in the center of the galaxy,
get to the
the
point.
density of stars is very high, and there are more supernovas and stuff. And there are things that could harass life right in the dead center regions of our galaxy.
Get to the point.
You also have the giant black hole at the very center of the galaxy. And if it were to have a close encounter with a star passing near it, it would rip it to shreds and form an accretion disk around it and emit lots
Which
of
would
radiation,
be
particle
awesome
radiation,
to observe.
electromagnetic radiation,
Not very healthy
gamma
though,
rays,
but
X-rays.
we're there again.
While a black hole, exploding stars, and deadly radiation would make complex life virtually impossible near the galactic core.
Stop. We have discovered that black holes are almost the perfect thing to create life, because the explosion of black holes, of supermassive black holes, created galaxies. Their accretion disk is pretty much the galaxy itself, things spinning around. The atoms, the dust, everything coalesced into stars, into planets, into planetesimals, into moons, into all kinds of amazing shit. If it wasn't for black holes, life wouldn't exist. And as for all these other horrifying, cruel, evil things that exist, they probably do serve some form of function.
Well, I think the point isn't that because black holes, because the black hole is there, there can't be life. It's more a case of you don't want to be too close to it.
I get that, but he's basically making the point that, in my eyes anyway, I could be completely wrong, he seems to be making the point that these things are out there, and if we were near them, we'd be dead, and it's horrible. I get that,
Yeah.
but he also seems to be saying that, you know, if we... I'm trying to figure out the best way to word this. He seems to be saying that these things are horrible, but thankfully we're nowhere near them. If we were near them, we would have a completely different way of doing things.
Yeah.
And we would have changed. We would have evolved a different way. We would have, even in terms of technology, we may have figured out a way to, at least for a brief period of time, ward off the devastating gravitational pull of a black hole. But
while I'm looking at the chat here, Wisdom Vendor is saying black holes aren't holes. That's a misnomer. Exactly. Thank you.
Yeah.
Because it's just a stupid name that is just someone picked it and it stuck.
Yeah, same as Big Bang, really.
Yeah.
Mm-hmm.
Okay, we shall carry on.
The outer edge of the Milky Way poses other challenges to habitability.
In the outer regions, the situation is much more subtle. We live on a planet made out of iron, magnesium, and silicon, and oxygen. If we went in the more distant regions of our galaxy, out towards the outer edge, the abundances of these elements are lower.
There probably aren't enough heavy elements to build Earth-sized planets that can support life. So there's a happy median between the dangerous galactic center and the outer edge of the galaxy.
But there's another good place we could observe this galaxy. Another galaxy.
Yeah.
Gonzalez, Brownlee, and Ward labeled this region, where complex life is possible within the Milky Way, the galactic habitable zone. Their theory was first published in 2001 and has since received growing acceptance among astrobiologists.
Whoa. They showed Scientific American. That is not a journal.
No.
Notice they don't mention
Science.
journal. They don't mention journals or peer review in that sentence. Or who the scientists
needs
are.
to be done to determine just how wide the habitable zone is. But I think there's general agreement that yes, there are definitely places in the galaxy that you cannot have civilizations.
Okay.
Because they're very dangerous.
Aye.
And there are places where you just have a very low abundance of heavy elements.
Okay, and?
While these obstacles to habitability are minimized far from the core and edge of the Milky Way, Gonzalez has also identified large areas within the galactic habitable zone itself, which are less hospitable to complex life.
Right out loud.
Even within the habitable zone in the galaxy, it's broken by the spiral arms, which are dangerous places. That's where most of the supernovae go off in the galaxy. That's where the star formation is taking place.
We don't want to be too close to a spiral arm. We want to be outside the spiral arm at about the right region of the galaxy.
It appears this is precisely where the Earth is located, in the relatively safe and uncrowded region, between the Sagittarius and Perseus arms of the Milky Way.
Location is everything, and so we occupy that special place in the galaxy where habitability is optimized, threats are minimized. We have enough building blocks to build an Earth.
Guillermo Gonzalez and Jay Richards have conducted research on another facet of the galactic habitable zone. They now argue that the Earth is also located in the best setting within our galaxy for astronomical research.
As it turns out, our position in the universe is not only critical for life, but it's also surprisingly important for making scientific discoveries. We're located near the midplane of the galaxy, a very highly flattened galaxy, between spiral arms in a region with very low dust extinction. While we are in the plane of the galaxy, that does not obscure a large part of the sky, so we can have very clear views.
For more than a century, this nearly ideal platform of observation has enabled astronomers to study the structure of the Milky Way. Looking toward the constellation Sagittarius on a clear night, for example, we see that the stars in our galaxy are not uniformly distributed across the sky.
Okay, so
instead they appear as part of a concentrated band, a flattened disk of stars, dust and gas, 100,000 light years in diameter.
The Milky Way band in the night sky is us looking edge-on into the plane of the galaxy. If we were living in the center of the galaxy, things would look much more spherically distributed. And so it will be very hard to distinguish things that are inside the galaxy from things that are
but
outside.
we've already established that we
And it's
couldn't
also
live
very
there,
dusty,
so it
much
doesn't
dustier
matter.
towards the galactic center than it is in our
Man
region.
has not stopped.
And so the views of the distant universe will be much more difficult
oh,
to
get
obtain,
to a
much more
point,
compromised.
please.
Similar problems would exist for astronomers working on a planet located within any of the galaxy's spiral arms.
But we don't
Here,
fucking live there, so it's not a
denser
fucking
concentrations of dust clouds and gas illuminated by stars would make it difficult to determine the shape of the Milky Way.
Yes,
Or to distinguish
it
the
would.
stars
What's
in our
your
galaxy
point?
from the rest of the universe.
That doesn't mean life can't exist there.
On the surface of the Earth, we're really in the optimum position for seeing both the nearby structure of the Milky Way galaxy,
No, we're
as
not.
well as seeing the distant cosmos as a whole. So once again, we see
Outside the
that
galaxy
best
would be even better,
location
wouldn't
for
it?
habitability and for producing a habitable planet is also the best overall position for scientific discovery, in this case at the galactic scale.
How did you figure that out?
Also, why is a philosopher talking science?
For centuries, the fact that we can discover things about the universe has really been something of a mystery. Why would beings like ourselves be able to discover a universe like this?
'Cause we got
Why is
brains.
What we think about the universe, why would it correspond?
Big old
to
brains.
Most of us do, anyway.
Our ability to discern and understand the universe is a fundamental part of what makes the universe tick, so that we're linked into it. This isn't just a sort of an accident, a trivial little byproduct. It is something that is linked to the great cosmic scheme of things. Now, I've no idea how that linkage works, why it's there, or anything of that sort, but I'm very, very struck by the fact that we can understand the universe in such exquisite detail and at such a deep level.
And
The
if we
spectacular
hadn't been
progress
able
of
to,
modern
guess what?
astronomy and physics is the product
We
of
wouldn't
a
be able to.
universe
It's that simple.
accessible to the human eye.
It doesn't mean
and
we
mind.
wouldn't be able to exist.
It is a universe governed by laws and forces that literally hold our planet Earth and the entire cosmos together, and are finely calibrated to allow for both complex life and scientific discovery.
If you didn't
Okay,
have
can
something
we
like
stop there?
gravity that pulled matter together.
Yeah, they just brought up some. They're going straight into the fine-tuning argument, which kind of begs the question: how do you know that these values are actually changed? That can actually be, they can actually change. How do you know that they could be
that's
something
one
else?
problem. Yeah, can we pause it?
Yeah, it's paused.
Oh, okay, it just hasn't caught up yet. But that's one problem with the fine-tuning argument. We don't know that they could be any different, but some things could definitely be different. For example, we know that things are receding and falling off the horizon of the universe. So at some point, there's going to be no other galaxy that we can actually see. And at that point, guess what? We wouldn't have been, a civilization that comes around at that time would not be able to discover the Big Bang Theory, for example. So the idea that there's this great plan that will allow for the universe to know itself or something like that, well, that's only true for a brief fraction of the universe's existence, because once those things fall off the horizon, guess what? They're not coming back, and time's gonna go on, to the best of our knowledge, infinitely into the future. So, hello, it looks like the universe is intelligently designed to not know about itself, if anything.
Okay, shall we carry on? We're getting near the end, so worry.
Together. You would never get planets, you wouldn't get stars, you wouldn't get any complex organisms. If you didn't have the strong nuclear force, there would be nothing to hold protons and neutrons together in the nucleus.
And
so
then
wouldn't
you
have any
wouldn't be
atoms,
here to
so
complain.
No chemistry. If you didn't have the electromagnetic force, you would have no bonding between chemicals. You'd have no light. And the list goes on. So you need all these sorts of fundamental principles have to be in place in order for life to occur. Wipe out one of those principles, wipe out one of those laws. No life.
But we've
Dramatic music.
During the past
But we've already done simulations to find that we can remove some of these forces. Or I can't remember which force
Not
it
the
is.
strong or electromagnetic force.
Right. But we.
And it's assuming that
possible.
these.
But what I'm saying is, it is possible to remove one of the laws that he says is totally needed. He's saying that all of these laws are perfectly made for such things to happen. But
I may have missed something. I thought he brought up the strong force and electromagnetism. Did he mention other forces?
And it's also assuming that these laws can actually be removed.
Yeah, that's another problem.
That's like we can just turn it off, but no, these are just natural reactions that just
And again,
are.
the laws are descriptive as well.
Yeah, that's also true. But we don't know. It is conceivable that there could be a universe without such laws, but we're not living in such a universe, so that's a moot point.
40 years, scientists have determined the relative strengths of each of these primary laws and forces. These strengths are so critically balanced, they are often described as being finely tuned.
If you're to take the basic fundamental constants of nature and you were to change these even slightly, or you were to pick their values at random, you would almost never get a universe that would be habitable in any sort of way.
Hit him with a brick.
That is, you
Hit him
couldn't
with a
have
brick.
galaxies,
Hit him
you
with a
couldn't have
brick.
planets,
And
couldn't have
can you
complex
demonstrate that they
biological
were
organisms
picked at random?
If these fundamental constants were even slightly different, slightly stronger, slightly weaker than they actually are in this universe. That's the idea of fine-tuning.
To better appreciate
What's your
this
point?
concept, imagine a machine able to control the strengths of each of the physical constants.
For making shit up, why not?
If you changed even slightly from its current setting, the strength of any one of these fundamental forces, such as gravity, the impact on complex life would be catastrophic.
If you increased it
You could
by a little
change
bit,
gravity quite a
no
bit.
large-scale life forms could exist. Anything that was more than the size of a pea would be completely crushed.
But what
So you
about
might
the
be able to
thing-
get
But you could
life
make it
of
smaller,
a very,
dumbass.
very primitive sort. Such as
Wait, he just said you might be able to get life. But it would be, well, that's the old goalpost shifting
It
again.
would be different.
Yeah. It would be
Right,
small.
so-
It'd be smaller, but it could still be intelligent.
And can we demonstrate that that the gravitational constant could have a different value?
Yeah.
I'm not sure we can.
Also,
And life
I
can
would,
adapt as well.
Yes.
I would
Keep
just
missing
like to
that.
point something out. We do have astronauts orbiting the Earth who are in 0 or very low levels of gravity who are perfectly fine.
Yeah, but that's not what he's talking about.
I know that, but I'm not trying to say that, because they're there, you can do it. I'm just saying that, life can survive in such environments.
Yeah.
It may be different for each planet.
Yeah, basically what he's on about is if gravity had been much stronger, then basically everything would collapse into black holes right away.
Oh, right. Sorry, I thought he meant like if it was different for the planet, not for the entire universe. I sort of dropped the ball there.
He's talking about big G, not little g.
Yeah.
Oh, right. Sorry.
But you could never get conscious observers.
This is one of a long...
How? You just said it would be small life, but it could still be intelligent in some kind of way.
Yeah, when was it established that
Size.
intelligence takes up space?
Yeah.
Also,
long list.
Sorry?
No, never mind. I was just going to say that elephants are pretty big, but they're not very smart.
Yeah.
Of properties in underlying physics that seem to be prerequisites for a universe with life. For example, the strengths of the other forces are all important. The masses of the various subatomic
you
particles.
stupid,
If all of these things were even a little bit
person.
different,
It would be
then
prerequisite
life,
in a
certainly life
universe
as
where
we know
there
it
is
couldn't
life.
exist.
Of
These
course,
forces and
that's the kind of
constants
universe we're
are
in.
another example of the correlation between life and discovery. For not only are they finely tuned for our existence, they can also be understood.
It's remarkable how well the laws work. And not only that, it's remarkable how simple they are. And that also is related to the discoverability of the laws.
Albert Einstein wrote, "I have deep faith that the principles of the universe will be both beautiful and simple."
Okay.
For nearly 400 years, scientists have discovered an elegant simplicity in the mathematical equations that express and unlock the laws of the cosmos.
Because we came up with the equations.
Theories
We
in
figure
theoretical physics can be written on a single sheet of paper. And this, I think, ought to be considered
And I
surprising.
really
that
object to
such
the
a
use of
simple
the word
formula or
faith.
equation could have such far-reaching applications to a very complicated and very large universe.
What you have is a universe that is not only finely tuned for life to occur, but also has a beautiful, elegant mathematical structure, and a structure such that we can discover that structure.
Yes,
Most scientists just take it for granted. That
if
the world
we
is both
invent mathematics and make
intelligible.
such
And
that it will be a
intelligible
useful
parts,
explanation for things, then yes, it will be a useful
It's one thing to
explanation for
accept the
things.
universe is ordered, but ordered in a way
That's not
that
amazing.
human beings are capable of understanding is an extraordinary thing. And so the question naturally arises, what is the explanation for that?
Many who have pondered this mystery of an intelligible universe argue that it cannot be easily explained away.
From naturalistic assumptions, you would not expect the universe to be understandable by human reason. After
Really?
all,
Why?
within the
Hey.
standard
Why
naturalistic
not?
story,
Why?
human reason was developed to be able to hunt prey, get around in the everyday world, attract mates.
We have certain skills, for example, we can jump streams and catch falling apples and so on.
And it
which
turns
are necessary
stop. It also turns out that intelligence gives us an advantage when it comes to surviving in the wild.
Yeah.
We developed technology. We didn't, reason how to, what was the example he used? Whatever, avoid prey. Fine. We also used our brain, our reasoning, our imagination to come up with this brilliant idea that, hey, if we put sharp rocks on sticks, that makes it easier to kill prey.
Mm-hmm.
Also, I just want...
Intelligence has an evolutionary advantage, even if it's not directly applied to survival.
Also, I would like to point out that if he's saying that, we as humans are really good at hunting and, doing all these things and creating this stuff, aren't there types of monkeys or apes even in the Congo that have developed hunting tactics based on one group runs, the other group traps, everything works out perfectly. That's intelligence, just in a different way.
Yeah.
It's in terms of hunting, but there's different levels of intelligence, is what I'm saying.